Today, ladies and gentlemen, we are going to be doing Unit 4, Note 6, which is special case factoring. So these are cases where there's a special method you can use. But just know that the method that we've been learning the past two notes will still hold true for these notes today. So first of all, let's talk about differences of squares. So if a quadratic is taking the form a squared minus c, you can use difference of squares. Basically, all that means is that there is no b term. There's no term that just has an x. So that is where difference of squares comes into play. There's a couple of other things that also have to be true. You can't just have no b term. There's a couple other things that you have to have. In order to use differences of squares, first of all, the b term must be 0. And also, any other term, the a, the x squared, and the c, all have to be perfect squares. So if you have something like x cubed, that's not a perfect square. You need to have an even exponent, x squared, x to the fourth, something like that in order to use perfect squares. Also, you need to have a plus sign and a minus sign. Now, I want you guys to know that it doesn't matter where the plus or minus sign is located. Most of the time you'll see the minus sign in the middle when you're looking at differences of squares. But to be totally honest, it doesn't matter which one you have. It doesn't matter where it is. Okay, so here are your steps for factoring differences of squares. First thing you want to do is check for a greatest common factor. This is something you always want to do when you are factoring. Okay, you want to make sure that you have a GCF. If you have it, you take it out. That makes your factoring life a lot easier. And in fact, when you're doing differences of squares, sometimes the differences of squares won't work out unless you take out that greatest common factor. Next thing you need to do is set up two factors. When I say that, all I'm asking you to do is to make two parentheses, just like you've been doing previously, but after the x. Next thing you're going to do is put a plus and a minus in each factor. That's the great thing about differences of squares. It's all set up the same. You're always going to have a plus and you're always going to have a minus. The next thing you need to do is put the square root of the first term in the first spot in each parenthesis. Again, this will make more sense as we actually apply it. The next thing you need to do is put the square root of the second term in both, this should say both parentheses in the second spot. Okay. So let's go ahead and try this. Let's take a look at number one. This is the most stereotypical example of a differences of squares. So first, check for a GCF. Well, between 1 and 25, I can't pull anything out, and I can't factor out any n squareds. So I'm going to go to step number 2. Step number 2 says to set up my two factors. So I'm writing out my two factors, and then I have a plus here and a minus here. So then I want to put the square root of the first term in each parenthesis. So I'm going to take n squared, and I want to take the square root of it. Okay, taking the square root of a square is just that thing itself. So n squared, when we take the square root, is just going to be n. Then we want to take a square root of the second term, which is 25. So then the square root of 25 is 5. I'm hoping at this point in your math career you know your perfect squares. You can recognize the numbers 4, 9, 16, 25, 36, and so on. If you know those, that will make your life a lot easier. If not, maybe just quick Google a list of perfect squares and just kind of get used to seeing them. Because seeing those perfect squares should trigger you into thinking, oh, I need to use differences of squares. Let's take a look at number 2. Number 2, you set up two parentheses. Okay, I forgot to check for a GCF. So between 36 and 49, there is no GCF. Between x squared and y squared, we can't take any x's or y's out. So what I'm going to do is I'm going to take the square root of 36, which is 6, put that in each. And then the square root of x squared is x. And then remember, we have a plus and a minus in each. For the second term, the square root of 49 is 7. The square root of y squared is y. So we have a plus in each and we have a minus in each. Okay? Let's take a look at another one. So I look at 3 and immediately I go, uh-oh, because I need a couple of things. First of all, currently I don't have a perfect square. I also have a cubed, which I know can't be a perfect square. So that taking out a GCF is extremely important here. So I have 48a cubed minus 12a. Well, what GCF I can take out? Let's take a look at factors of 48. I have 1 and 48, 2 and 24, 3 and 14, and 4 and 12. Okay, so I see that I have a 12 here. And I know that factors of 12, I'm going to have a 1 in 12. So I immediately know right now that I can pull out a factor, or a greatest common factor of 12. If you look at both terms, here I have an a cubed and an a, so I know I can factor out an a. So I'm going to divide each of those terms by 12a. When I do that, 48 divided by 12 is 4, and I'm left with a squared. 12a over 12a is 1. Now, students forget this a lot, but 1 is actually a perfect square. 1 times 1 is 1, so we can take the square root of 1. So this is really going to lead up to doing the same thing. The biggest mistake I see students make is they leave the GCF. Now, I commonly refer to the greatest common factor as your little sister. When you're going through and you're doing factoring, you know, when you bring your sister to the mall, you know, you always have to have her there, but you can kind of ignore her, but you always have to keep her there. You can't lose her. You'll get in trouble. That's kind of how the GCF is. You just kind of keep her there. You can ignore her, but you can't leave her behind. Otherwise, you'll be in trouble. So what I'm going to do to help myself is I'm going to rewrite out this 12a again, and I'm going to write it multiplied next to my two parentheses. So I'm going to put a plus in one and a minus in the other. First thing I want to do is look at 4a squared. I want to take the square root. Well, the square root of 4 is 2. The square root of a squared is a. Next, I want to take the square root of the second term. The square root of 1 is 1. So put that in each. Okay, so I'm going to go ahead and do number 4 as well. So let's take a look at number 4. So for number 4, I can factor out an x. I know that. And then I'm left with 9x squared minus 4. This is a good thing because it gives me my perfect square. So again, I don't want to leave my little sister in the woods. So I'm going to keep her on the outside, but I can just ignore her. She's not bothering me right now. So then I need to take the square root of the first term. Square root of 9 is 3. Square root of x squared is x. A plus in 1, a minus in 1. The square root of 4 is 2. So that goes in each. So again, if you're stuck, if you're still not understanding this, try rewinding it and watching it again. What I'm going to have you do right now is try these two on your own. I'm going to remind you for number 6, it doesn't matter where that minus sign is located. All right, let's talk about perfect squares. So sometimes when you factor, the factors end up being identical. So there's a special way that we can write that out. And when they're identical, you write them out like this. So we have x minus 4 times x minus 4. That can actually be written as x minus 4 squared. What that squared is telling us is that there's two of the exact same things being multiplied together. Okay, so that is what we're working towards. Okay, let's take a look at number 7. So for number 7, first thing I want to do with perfect squares, I'm going to be factoring it just like normal. But again, guys, try and find those GCFs. It makes your life a lot easier. I know that 16, 32, and 64 can all be divided by 8. If that's not something you see easily, go ahead and write out those factor lists. Pull out the biggest number. So then I'm going to factor 8 out of each of these. So that gives me a lot smaller of coefficients. Then I'm left with 2x squared plus 4x plus 8. Okay. So next, when I'm setting up my x, I want to multiply my outside terms. 2 times 8 is 16. And then my middle term is 4. Okay. Now I need to come up with factors of 16 that multiply to 4. Well, I have 1 and 16, 2 and 8, 4 and 4. All of them are going to be positive. There is no way I can get anything to add up to 4. So what does that tell us? Well, that tells us that this one actually is not factorable. We were looking to get two identical factors, but that's not going to happen for us. Okay, that happens every once in a while, and I want you to remember that. So before you come running saying this one, I can't get it to work, first of all, check that you've done all your factors. If you've done all your factors, there is that chance that it's not factorable. Let's take a look at number 8. So for number 8, what you're going to do is I want to set up my x. Okay. So when I set up my x, I need to take my outside terms. 9 times 4 is 36, and they're going to add to a negative 12. What multiplies to 36 and adds to negative 12? Well, because I have a positive product, negative sum, both my signs are negative. So I'm going to have negative 6 and negative 6. So now I want to rewrite out that equation. My a is not equal to 1. We talked about this earlier. So since my a is not equal to 1, I am going to rewrite out my equation, splitting up that b term as minus 6y minus 6y. So then I can go ahead and group it. Between 9 and 6, I can pull out a 3, and I can also take out a y, which leaves me with 3y minus 2. From this parenthesis, I can take out a minus 2. Remember, this sign's negative, so I'm taking out a negative 2. And then I have 3y minus 2. So when I write my factors out, I have 3y minus 2 times 3y minus 2. Well, those are identical. So what I'm actually going to do is, instead of leaving it like that, I'm going to write it as 3y minus 2 squared. Writing it as 3y minus 2 squared. So now we're going to go ahead and move on to our next one. All right, what I'm going to have you guys do is I'm going to have you guys try number 9 on your own. Okay, so note that a is equal to 1. So think about which method you need to use. Let's go ahead and try number 10 together. First of all, I see that each of those numbers are even. You know what that tells me? That tells me I can pull out at least a greatest common factor of 2. And it turns out that 2 is the largest greatest common factor I can take out. So I'm going to divide each of these by 2. When I do that, I'm left with 25g squared plus 20g plus 4. Okay, so remember, that's like your little sister. You can't lose her. So let's go ahead and multiply this out in our x. So we have 25 times 4, so we're multiplying to 100 and adding to 20. Well, what multiplies to 100 and adds to 20? Well, that's 10. So right now, for the purposes of keeping things neat, I'm just going to set my GCF aside. But remember, when you leave the mall, you need to have your little sister with you. Okay, so I'm going to write this out as 25g squared plus 10g plus 10g plus 4. So now I'm going to go ahead and factor by grouping. Out of here, I can pull out a 5g, and I'm left with 5g plus 2. Out of here, I can pull out a 2, and I'm left with 5g plus 2. So now I know I have 5g plus 2 times 5g plus 2. We don't want to leave our little sister at the mall, so we need to make sure that that GCF comes down to our answer. So now I have my 2, and I can take this 5g plus 2, and I'm just going to square that part. The 2 isn't being squared here, but I'm going to square that part so that I can get my answer simplified. Okay, I'm going to go ahead and get you started on number 11, and then I want you to try number 11 and number 12 on your own. So first of all, before you go anywhere on number 11, you have to pull out a greatest common factor. So we're going to pull out a greatest common factor of 3t. Okay, you can't factor if you have a cube term. Factoring only works when the greatest exponent is 2. So then you're left with 3t squared plus 11t minus 16. So go ahead and set up your x. You get negative 48 and 22. That should be 22, not 11. Silly me. Okay? So I will tell you that the things that multiply to negative 48 and add to 22 are 24 and negative 2. So what I want you to do right now is to set it up. Okay, so we're going to ignore our little sister right now. So we have 3t squared plus 24t minus 2t minus 16. So I want you to go ahead and factor that by grouping. Okay, then I want you to try number 12. I'll tell you that number 11 does not come out to have 2 perfect squares. Okay, it's not going to be the same factor, and that's okay. So try number 11, try number 12. Once you're done, please remember to take the quiz at the end of the video. Thank you.